I have started the recording, ma'am.
Good afternoon, Dr. Pallavi.
Good afternoon, Habiba.
Good afternoon.
Okay.
So,
Good afternoon, everyone. So we are again meeting for this third. Hello, am I audible?
hello. Good afternoon, Dr. Ganga.
Yes, yes, ma'am. Please.
Ma'am, your voice is breaking in between.
Breaking. Okay.
Now it's okay. Now it's okay.
Is it clear now?
Yes, yes, yes.
Yes, yes. Now it's
Now it's
clear.
okay.
Yes, yes.
Okay. Okay. Okay. Okay. So we are again meeting. Good afternoon, everyone. This is the third webinar in this series, and today the webinar will be delivered by. Now, let me just introduction about Dr. Pallavi. So Dr. Pallavi is an associate professor in the Department of Computer Science and Engineering at Galgotias University, and she is the head of Computer Graphics and Digital Image Processing Research Group here. She has over 12 years of teaching experience and has 5 years of research experience as well. She has done her post-graduation from Allahabad University and her PhD in computer application from Mewar University, Chittorgarh. She has been awarded Best Teacher Award in year 2010, and she has authored 2 books on computer fundamentals and business data processing for CCS University. She has around 10 research paper publications in international and national journals and has 4 Indian patents as well as 1 German patent to her credit. So without taking much time, over to you, Dr. Pallavi, so you can start with the webinar. Thank you.
Okay, thank you, ma'am, for such a wonderful introduction to me. Am I audible to all of you? First of all,
Yes, yes, of
I want to
course.
check.
Of course,
Okay.
Dr. Mawar.
Okay, can I share my screen now?
Yes, of course.
Okay. My screen is visible.
Yes, yes. Now it's visible.
Okay.
You can start.
Okay.
Visible.
Okay. Now I'm starting now. As Dr. Ganga ma'am introduced me, I'm Dr. Pallavi Jain from Galgotias University, and I'm here for since many years. Okay, so I'm very glad to be presented over here for on the recent topic data centric computer vision in this webinar series related to the AI. So in this lecture, we will walk through computer vision approaches, applications, sharing techniques, and best practices for launching successful computer vision based models. So first of all, we will understand what is data centric approach. Okay, just the data centric approach mainly focuses on primarily on providing quality data. That is, instead of solely focusing on choosing algorithm, actually we are busy in choosing algorithm, machine learning algorithm. Here we put this algorithm, here we put this algorithm, but now this approach is basically focuses on the choosing algorithm. We have to spend time on gathering and annotating data, correcting mislabeled data, augmenting data, and scaling this type of process. So the main and foremost advantage of data-centric model gives a massive financial lead to enterprises adopting this approach, and starting with savings on infrastructure and reduction in other recurring costs makes the entire enterprise data smart by choosing this data centric approach. So I will do the slideshow. Now, these are the table of contents of my lecture. That is, firstly, we will I will give the introduction about this topic, then factors driving growth in computer vision, then approaches to computer vision, then annotating a computer vision project, then real life applications challenging in the field of computer vision, and then considerations for success in the future. Now, first of all, the introduction part. So the world of computer vision is full of inputs, that come in all forms of text, images, and video. So just like machine learning algorithms have enabled us to extract information from text, recent developments in the fields of computer vision have made it possible to glean insight from image and video as well. As you all know, computer vision, a subdomain of AI, seeks to teach computers to see in the way in order to understand the content of digital media, right? So human vision systems have the advantage of learning from a lifetime of experiences to how to contextualize the things we see, right? So the field of with the introduction of deep learning, with the mixing of in data centric approach, we can say like that, with the mixing of deep learning and neural network techniques, this field of computer vision is experiencing a high growth. Today, a computer vision system can recognize objects in images, video, including their shape, textures, color, sizes, locations, movements, and other relevant characteristics. So, uh, first of all, basically data centric, why we choose data centric approach, as I have discussed earlier, now also. So data centric AI is the discipline of systematically engineering the data, that is programming with focus on data instead of coding or algo and all. For first of all, we need to focus on data. It should be uh, it is a food to AI or computer vision, right? So now the factors driving growth in computer vision. So uh, computer vision is much more complicated now due to the advances in machine learning, but also exceedingly more useful thanks to a variety of factors, just like data, imaging devices, processing power, annotation tools, cost, algorithms, and techniques that have helped unlock untapped potential in the field. So first of all, data. Using cameras, sensors, scanners, and innovative new imaging technology, there are plenty of opportunities to create more data for computer vision projects, right? The expansion of data storage options, particularly with regards to the cloud, has likewise increased the availability of the data. By 2023, researchers predict that the majority of enterprises will store their data on the cloud, right? So the data is very much important. Now, second is imaging devices. Technological advancement in image capturing, hardware and software provide greater accuracy for image analysis. Now, third one is processing power. There has been significant improvement in the last few years in the ability to process large volumes of data quickly and effectively, right? Now, next is annotation tools. Basically, annotation, what is annotation? Annotation is adding something in like the comment or extra information to any text or image. Annotation is like that. Okay, so organizations have at their disposal a growing selection of annotation tools available for data labeling purposes. It improving process speeds and driving scalability. So there are basically several open source annotation tools available, as well as third party vendors that provide access to their own annotation platforms, right? Now, next is cost. The cost of computing continues to drop exponentially. In some estimates, computer power available per dollar has increased by tenfold. After a survey, I came to a judgment that in some estimates, computer power available per dollar has increased by tenfold every 4 years in the last 25 years. Now, next is algorithms and techniques. So, computer vision has many sub areas such as object detection, object classification, object segmentation, and object tracking. Open source machine learning models encourage more rapid experimentation across multiple industries. So basically, various types of models, various types of algos of AI and ML and deep learning, we can put over here with the computer vision to for our research part also, right? Next is approaches to computer vision. Next is very important, various approaches to computer vision. So computer vision may have around for decades, but applying machine learning to the discipline is what launched it to the forefront of the innovation. While deep learning, that is a subdomain of ML, is considered the cutting edge technique in computer vision, there are other approaches that can work depending on their use cases. So basically, the standard machine learning approach, basically we use two types of approaches here. The standard machine learning approach, it is a non-deep learning approach, typically requires engineers to handcraft visual features to be used in their computer vision task. Okay, so in this approach, humans explicitly tell the algorithm what to look for. Okay, so and in the deep learning approach, it rely on artificial neurons in a network such as convolutional neural networks is well-known algorithm CNN to learn their connections to the to other neurons. In this approach, visual features, which we features feature extraction, I'm depicting over here, and classification also. So in this approach, visual features are automatically learned from input data instead of hard coded by engineers. So it has been shown in many computer vision areas that this approach can outperform traditional machine learning algorithms and even achieve superhuman accuracy. In this in the future, we can in the daily life we can apply neural network also here. Okay, so provide the algorithm with two data sets, one with only images of cars and one with that contain no cars, right? And the CNN compares with the data sets, extracting features and patterns to create rules. Using these rules, the CNN produces a deep learning model that can isolate car features here, right? So next, annotating a computer vision project. Annotating a computer vision project. So here, what is annotation? As I said earlier, an annotation is extra information associated with a particular point in a document or other piece of information. Okay, when we write something, when we write in text or when we draw some image, we want to add some extra information for the reference part, right? So associated with a particular point or in a document or other piece of information, so it includes a comment or explanation, right? And image annotation is a process of labeling images in a given data set to train machine learning models, just like, right? So just like we are seeing the image, uh, any query, Monica?
No, ma'am.
Okay.
Oh, sorry.
Okay. Okay, it's okay. So in annotation, regardless where you source your data, you need to sure of three things. Your data should be protected and secure, especially if it contains personal information, or it should be complete in all use cases and edge cases and in type of flow charts and all, and it should be clean and precise, right? So traditionally humans have manually labeled all of the data in a machine learning project. Now we have tools that help to automate at least a portion of this process. Okay, for example, you can use a pre-trained model to make an initial hypothesis of your data labels. Human annotators will then check that hypothesis for accuracy. Is it accurate or not, right? So use a model to assist with labeling during the job, and use a model to validate a human annotator's label. prior to submitting the job as a form of quality assurance, right? So in this image, in this center image of cytoplasm, so it is an example of pixel level semantic segmentation. In image segmentation we have done the pixel level semantic segmentation job annotating a cell. We are here annotating a cell. So example of this is an example of output where we give as a input, cytoplasm is depicted as a pink shaded wall around the cell, as you all see. Here class name will be the cytoplasm and display color will be the hexadecimal code for peach pink, right? And the nucleus is depicted as a small round matter within the cell, pink color. Class name is nucleus, and according to the color we have give here. Next is image annotation. In image annotation, annotators add metadata or text to image data to identify the features the model needs to learn to recognize, right? So the algorithm processes these labeled images, just like you are seeing the images of 2D bounding boxes and 3D point cloud annotation. I'm telling here. So the algorithm processes these labeled images, learning from these examples how to identify the features in fresh or unlabeled data. As technology advances, annotators have been able to rely more on machine learning assisted features often built into data annotation tools, which help to automate parts of the annotation processes, increasing efficiency and accuracy, right? So different type of image annotation exists for different purposes as highlighted below. So first of all, that is image classification. Why we do image classification and what is that? So there are different features in the computer vision which we can perform with an image, right? So image classification asks the question, what kind of object in this photograph, right? So it doesn't attempt to localize the object within the image, only to ascertain whether the object is there, is that. So classification helps you to understand how much data you have of each type and filter out any unnecessary units of data. The limitation of classification is that it's vague and only useful for simpler tasks, right? Now second is object detection. Object detection asks, where are the objects in the image? In the image, where are the objects to detect? It provides the target object's general location using a number of annotation techniques. So for first technique I have applied here is 2D bounding boxes, right? So a bounding box is a rectangle or a square that serves as a point of reference for object detection. Annotators apply bounding boxes to define the x and y coordinates of the target objects in an image, just like you are seeing the seeing here multiple trays of vegetables and all. So here the class name will be the price, broccoli, green beans, है ना? And coordinates will be the h colon 85, suppose w comma w colon 92, suppose for width and height, and x and y coordinates and all like that. And now that is 3D point cloud annotation. If you are working with radar or lidar data, you will have a 3D model of the image. Without 3D model you can't work. A 2D bounding box wouldn't work accurately in this case. So annotators must use 3D bounding boxes or cuboids, as you are seeing for vehicles, and as you seeing in the picture. Also, these cuboids, when applied, localize the target object and indicates its depth. This is also known as point cloud annotation, right? So these are the various techniques which we can use for image object, image classification and image detection, and a different type of image annotation and all. Now real life applications where we can use these types of techniques, right? So almost every time you order a package, enter a store, or watch a movie with CGI computer graphics interface, you are interacting with computer vision. Okay, in every field, right? So computer vision solutions are more ubiquitous in our daily lives. then we probably realize that's because every major industry has incorporated computer vision into their business operations, right? So now first and foremost, field is augmented reality and virtual reality. AR or VR. This is the most recent concept nowadays of computer vision. So AI models can offer an easier and more scalable way to provide the inputs required to build seamless and impressive AR VR experiences. So the most common way is by recognizing data inputs and triggering an effect within the AR VR scene. For example, you using image and scene labeling to classify an image and trigger an AR label to the displayed, or text recognition and translation to detect, read, and translate text in an image. So augmented reality APIs are then used to overlay translated text back to the 3D world, right? So next is autonomous vehicles. One of the biggest adopters of computer vision technology are automotive companies striving to make autonomous vehicles, right? So this use case highlights so many types of image and video annotations working together. In vehicles, in automobile industry, there is a vast use of computer vision. For example, using video object and event tracking to understand how objects move through time. This is useful for tracking pedestrians, cars, cyclists, and as they enter and exit the area of interest over many frames of videos and LiDAR scenes, right? So next is the healthcare. CV and computer vision and healthcare are a natural fit due to the availability of medical imaging data. Doctors at many hospitals use computer vision to support and supplement their diagnosis algorithm and analyze images. If we do MRIs, X-rays, CT scans to identify signs of infection or disease. In many cases, deep learning neural networks are trained to extract features from medical images to learn how to identify anomalies there. For more precise image analysis, teams require pixel-level semantic segmentation that we have done with the cytoplasm to identify tiny polyps or tumors for certain types of cancer. In both scenarios, computer vision has potentially life-saving implications. A lesser known use case in healthcare is also early detection of autism in children, the major research industry for that. Computer vision based AI can apply gaze tracking algorithms to identify unusual patterns early on, which could indicate cognitive impairments, etc. So next is retail. Computer vision systems track customer behavior in stores to provide retailers important insights on customer needs. For example, cameras can track movement patterns, detecting which areas of store experience more frequent traffic. The AI can also track customer gaze, seeing which displays attract the most attention. Okay, so using this behavioral analytics, retailers can set up their store layouts to drive the most sales. Retailers can also use computer vision with facial recognition. There are various human fault recognition, facial recognitions to automatically spot suspicious behavior or known shoplifters, leading to improved loss prevention. So this is very helpful there. Next is manufacturing. Predictive maintenance is just a way. Computer vision benefits manufacturers, right? So cameras and sensors installed on equipment monitor for potential maintenance needs, and a computer vision algorithm can indicate when those needs must be met prior to any downtime or significant repairs. Prior to downtime or significant repair. So computer vision systems are also used to monitor product quality, quickly detecting defects in components, and manufacturers can then take swift action to manage the issues accordingly. right? Last but not the least, this is agriculture. In recent years, the farming industry has become increasingly tech savvy, right? So there are several applications of computer vision, in agriculture, using drone imaging and pixel level semantic segmentation and images of crops and weeds. Farmers can pinpoint the exact areas of the field to spray fertilizer, not all on the whole crop, to spray fertilizer versus pesticides, decreasing waste and all. Farmers also use object detection to predict crop diseases or pest infestations, allowing them to manage the situation before it becomes too late to destroy, before destroying. So farmers also use computer vision algorithms to sort crops by size, weight, or quality, enabling more efficient distribution. Okay, so there is an announcement. This meeting will be ended in 10 minutes. Okay, if you have any query, any question, then you will rejoin again. In 10 minutes, I will wind up my lecture. Next is the challenges in the field of computer vision. So launching a successful computer vision project isn't without its challenges. So every side has two coins, okay, advantages and disadvantages, as it is benefits and challenges. Okay, so now the first challenge is understanding human vision, right? To mimic the perspective qualities of the human eye and the brain is not an easy feat, right? We still don't have a full understanding of how human vision works, how its biological parts functions, and how the brain interprets what we see, like that. Okay, so this is a big challenge. Next, complexity of visuals. We can see and identify objects from various orientations, lighting conditions, and obstructions. Next is label consistency, determining classes and labels, differentiating them enough from each other to be meaningful. So it is an important step in a computer vision and annotation project. Next is data collection. Data collection is again a very challenging task to collect the appropriate data. Next is considerations for success. So computer vision is a prime area of opportunity for organizations looking to get into the AI game. So if you are thinking about launching a CV computer vision project, there are several best practices to consider before getting started, right? So there should be we should be define our scope, begin your project with a clean and narrow definition of your business goal, determine success criteria, decide and clear mathematical metrics that will indicate success of your project, integrate resources, leverage both human and machine to drive speedy, efficient and deployments. Next is build to scale. Construct a scalable automated training data pipeline for two reasons. One, you can use this pipeline to continuously retain your model, and two, you can replicate this pipeline in future projects according to the maintenance, according to the recent scenarios. And last is plan to iterate. The process of building out a computer vision model is one of the frequent iteration. Your initial requirements will likely change throughout the project as you discover more edge cases, and they need to be accounted for and work toward higher performing models. So this is all about my presentation, and these are the references from which I have managed my I have I took my matter for to speak for the presentation. And thanks a lot. And this is all about the consideration of computer vision technology, data centric approach of which is a combination of AI, ML, and computer vision, computer graphics. Basically, I'm the computer graphics and digital image processing research group head here. So choose I have chosen this topic according to the AI and ML. Thank you. Thanks a lot. Any queries? No queries?
Yeah, colleagues.
Yes, sir.
I have one question.
Okay, sir.
Can you say me what algorithms do you use in the face detection risk section of computer vision?
Okay.
And
Okay. In human fault detection or human human recognition, human movements recognition, we have used CNN, KNN, and rainforest algorithm of AI and
AI.
etc.
Okay.
Machine learning,
Okay.
AI and ML. And by this, we can detect the human fault, human fault movements, and design the phase detection also, and human movements detection, and we can work on semantic segmentation and all.
Yes.
This is a recent research area, I think, nowadays.
Yes.
And medical segmentation also, medical imaging also, through CT scans and CT scans, MRI we can use.
Yes. So you have also used human pose recognition also, CNN and neural networks algorithms and
Yes, we can
IE
use.
algorithms.
Yes,
We can use.
these are the latest trends. And
Okay.
this is and nowadays this is an emerging technology.
Imaging technology. Okay.
One question.
Yes, sir.
I have one question.
Yes, sir. Yes, sir. Please welcome.
Thank you. What mathematical models did you use in the digital processing of images?
Pardon? What processes for the
Mathematical models.
which
He
models?
asked mathematical models.
Okay, for mathematical models. Okay, we use a model centric approach there. We collect what data, what we can at maximum, and develop a model good enough to deal with. Okay, so in the noise of the data, so we hold the data fixed and iteratively improve the code or model. Okay, and we use KNN model, rainforest model. Okay, we use CNN model, VMM model for the mathematical calculations of the human ball, or related to the computer vision projects. These are all the combinations of AI, ML, computer vision, computer graphics, medical imaging, and all.
Thank you for your presentation, Dr. Pallavi. Also, I have one question.
Okay.
Also my research topic is medical image processing.
Okay.
Until now, I have collected 1,500 mammogram images in DCOM files.
Okay, very nice.
I would like to classify these mammogram images into three classes: normal, benign, and malignant types.
Okay.
How many mammograms are enough for classification? I choose CNN model,
Okay.
convolutional neural network.
Okay.
And can you give me some recommendation for my research?
Okay, you can use the page segmentation. Okay, pixel level semantic segmentation first there. Okay, you should use pixel level semantic segmentation for annotating your image, right? So after that, you will get the exact level of the size and exact position of the coordinates, x and y coordinates of that particular image or particular section of the image. Okay, so after that you will find the images better. So first of all, you will have to do this pixel level semantic segmentation for that. right?
So, okay, thank you.
Yes.
And so next question. So I wrote an article about image processing,
Okay.
and I use it type 2 fuzzy set theory, fuzzy set method for segmentation.
Okay.
So is it a good approach?
Yes,
for
yes, yes. Very nice approach and
segmentation?
very recent approach. It is related to the pixel level semantic segmentation.
Okay.
Yes,
Thank you.
it is a very nice approach and recent approach you use
And
here.
also, I studied about classification. So in one article, so scientists take mammogram in.
Okay. Yeah, I can record now. Yeah, more questions? Anybody?
Yes, I have.
Yes.
one
Yes,
question.
yes, you can, please.
Okay.
Вы можете сейчас.
Miss Habiba, are you here? You were asking the question.
Yeah, yes, of course, I'm here.
Yes.
So
Yes.
can I start my question?
Yes.
So,
Yes. Yes.
Dr. Pallavi, so I took decom files. You know, there are 6 categories in
Yes.
BRATS.
Yes. Yes. Yes. Yes.
So, and I took every form of mammograms,
Okay.
cardiocoronal and mediolateral oblique view of mammograms.
Okay.
For each patient, there are 4 mammogram images for each patient.
Okay. Okay. Okay.
I would like to take every image
Okay.
for as a one case.
Okay.
Is it true?
Yes. Yes. True.
So
True. True. And you also do polygonal segmentation for that. In that, here is there will be the landmarks, lines, and splines, and ontology attributes for that. That will be helpful for your research. That will be
Okay.
very helpful for your research prospect.
Okay,
Right?
thank you. Okay, and could you recommend me some kind of articles or?
Okay, I will share. Please email me your email ID or message me your email ID. Okay. My email
Okay.
ID is pallavi.jain@galgotias university.edu.in. You email me your address, then I will share some recent articles and research papers for your research that will be really helpful for you.
Okay, and could we write or some kind of research paper jointly?
Obviously, sure, deadly sure.
Okay, thank you.
Huh.
Okay, thank you.
So make me contact. You will contact with me. Okay. Make contact
Okay,
with
thank
me.
you. So, dear colleagues, do you have any questions?
Yes, I have one question.
Okay, just tell me.
How to labeling multi-temporal satellite imagery for classification and image spatial resolution is 10 meters and 12 bands. Really, human eye cannot identify crop type in this image, but how to labeling is this image and what kind of annotation tools need to labeling?
Yes, annotation tools are for the object detection, are for 2D bounding boxes, 3D point cloud. Annotation tool is very good tool for annotation, vehicle use cases, as well as polygonal segmentation, landmarks, ontology attributes for image annotation. Instance versus semantic segmentation. These are the techniques for the annotating your image. Instance segmentation, semantic segmentation is really very wonderful technique for the image annotation.
These tools work with satellite imagery because human eye cannot identify crop type.
Yes,
in satellite imagery because
yes, for that you use image transcription. image transcription is the process. Sometimes images contain text that needs to be captured and then transcribed. While annotators can do this manually through the use of bounding boxes and text input fields. So automated tools are much faster. So use image transcription there. Right?
Thank you. Thank you.
Okay. Any more queries you have?
So, dear colleagues, do you have any questions?
Okay, it's enough.
I think
Pallavi.
I think my session will be really helpful for you all for the
Yes,
research.
yes, of course. It was
For
so
the
interesting and
for the research
helpful.
prospect. Okay. Thank you so much. I'm really glad to present over here in front of you all. Thank you so much.
Thank you.
Thank you.
Thank you so much.
Dr. Pallavi, can you send by Telegram your presentation?
Pardon?
Can you send your presentation by Telegram?
Okay. I can.
Thank you.
I will manage.
Okay.
Thank you.
Dr. Pallavi, good day. One more. Thank you for your presentation.
Okay, so
And
thanks a lot.
please, can I ask from which place you give us your presentation? Can you describe
Sir,
the place where you are
sir,
placed now?
Sir, I have included here the reference. I have basically referred the app and ebook computer vision and significance of it. There are the references through which I have taken the most data I have taken from app and ebook computer vision, sir, because this was totally related to my topic.
Thank you, doctor. But I ask some another thing. I very wondered your office. It's very interesting. You in your office there are many computers. And
Actually,
I wondered which kind of office is this?
actually, I'm sitting in the lab, not in my cabin. I am sitting in the lab because here internet connectivity is very much good. So I am sitting in the lab right now, not at my cabin, university cabin.
Which kind of the laboratory is?
Computer lab. It is the computer lab. It is the computer lab here. A lot of desktops are there. So here internet connectivity is the main. Here that's why I have chosen this place.
Okay, thank you.
Thanks a lot. Have a nice day.
Okay, thank you.
Thank you. Have a nice day.
Okay.
See you next webinar.
Jai Hind.
Nakana Habiba, John Beg, Nakana Pressaga Billinger, Nakalarda.
Assalamualaikum.
Assalamualaikum. Dr. Ganga, I am Akmal Akhat, Vice Rector of the International Cooperation. And I am specialist in IT too. Very thanks for the organizing such seminars. And please
Thank you.
Please say our thanks to Dr. Manish, who was
Sure,
at the
sir.
head
Sure.
of this
Sure.
seminar. Yes. Hey,
Definitely.
I'm inviting all of you to Samarkand. Please come to Samarkand and give your presentation in the offline, not online.
Thank you, sir.
Oh, sure, sir.
Thank you for the
That will
invitation,
do.
sir.
That will be a great
Thank you very
opportunity
much.
for us all.
I say
Thank you,
our
sir.
colleagues.
So,
Please say, please.
yeah, I was just saying that can we all just turn on our videos so that we can have a picture together? Please turn on your videos so that we can have a picture, photograph.
İltimas hammalaringiz videolaringizni yoqingizlar, rasmga olaman deyapti.
Yes. And
Thank you.
Right now, I ask it to our colleagues to share the information about this conference to media. Okay.
Thank you, everyone. Thank you.
Okay, thank you.
Thank you so much for joining.
Dr. Sharma. Okay.
Next week again, I'll share you the details,
Thank you.
and most probably we will also plan that session from your end also, the presentation from your research scholar. So we'll plan that next Saturday, definitely.
Yes, of course, Dr. Sharma. So from our center, San of Otabek will present his lecture. So next week we plan about this webinar. I will send you all details to your Telegram account and to your email.
Okay, thank you.
Okay,
goodbye.
Thank you, everyone.
So sorry, Dr. Sharma. Next Saturday we have so celebration.
Vacation or holiday.
Yes,
Independence
vacation we
Day.
have. So
Our Independence
next
Day.
Saturday
no problem. So
is third of September. It's our Independence Day
yes.
vacation. That's why we'll plan in 10th of September. Okay.
Okay, no problem in that. We'll plan
Thank you.
accordingly.
Goodbye.
Okay.
Thank you for your
Okay, goodbye from here. Thank you.
presentation. Okay.
Okay, goodbye.
Thank you so much for
Goodbye
joining.
to all of you.
Bye.
Thank you. Goodbye.